This discussion will introduce the concept of linearization. Well, introduce may be a poor term since we've actually been using linearization anytime we've found a tangent line, but we're going to think of the tangent line with a different purpose. But here we have the equation of a line given some point and slope. This is the point and slope formula for the equation of a line. But what we want to do is reinterpret the symbols. So if we can just use this paper here. Let's reinterpret these symbols. Well, let's first solve for y. If we solve for y, we move the y sub 1 over. We get y sub 1 plus m times x minus x sub 1. But we're trying to find the equation of the tangent line. Well, the y value for the point of tangency is the function evaluated at the given x value. And the slope is the derivative of the function evaluated at the given x value. So here we have the same equation reinterpreted. Now let's let our special x value, let the x of 1 equal a. Well, if we do that, we have y equals the function evaluated at a plus the slope is the derivative of the function evaluated at a times x minus a. Now this is the equation of the line tangent to f at a. We call this the linearization function, and we use L of x to denote the linearization function, and we call this the linearization function of f of x when x is a. So this is the linearization of f when x equals a. And what you use this function for is to approximate values of the function when you are close to a. So let's say you're looking at some function running around doing whatever it wants to do, but you find the tangent line at some value. Let's find this tangent line at a. Well, we see that the tangent line hugs the curve for a small little interval. So instead of using the curve, the function that describes the curve, f of x, we could use to approximate the curve if we needed to know what the value of the f of x is at some number close to a. We could plug it into L of x here and get an approximation because L of x is very close to f of x. Now, of course, it doesn't work for all a values. We see that if we were to come over here into the negative land, suddenly this particular L of x doesn't approximate f of x very well at all. But for values close to a, it would. And that's what we use linearization for.